If you're just joining us in this channel, make sure you like the video, share the video with your friends, and also subscribe to the channel. Okay, so if this video is blurred in your device, try to increase your YouTube resolution power so that you should see the video clearly. So let's get started. Alright, so in fact I think we know the instructions. 1 hour 30 minutes, and paper 1 of further math is 20% of the GCE. But the funny thing is that it gets across paper 2 and paper 3. So we begin with the first question. Here's the first question. X squared. The question says x squared plus 1 divided by 1 minus x squared, where x is not equal to plus or minus 1, expressed in partial fractions where a, b are all real numbers. So we need to get the expression of this in partial fractions. So what is the expression of x squared plus 1 divided by 1 minus x squared? So what we are trying to express is x squared so question 1 x squared plus 1 divided by 1 minus x squared. Alright, so the first thing to do is we need to look at the degrees of the numerator and the denominator. They have the same degrees. The degree of the numerator is 2, the degree of the denominator is 2. So when the degrees are the same, we start by doing long division. Alright, so I'll just show you a little trick because I'm typing the solution, so it's going to be a little bit tedious to go and be drawing lines to do long division. So I'm just going to show you a little trick, but I prefer you do long division if you don't understand this trick, and we are still going to have the same answer. So for me to do long division without actually carrying out long division, I will create the numerator, I will create the denominator in the numerator. So I will start by writing the numerator as the denominator. Alright, then I'm going to do something to the numerator to get back my denominator. Okay, so in fact, for us not to get confused, we can factorize the negative sign so that the denominator becomes x squared minus 1 and the numerator still stays as x squared plus 1. This negative sign will multiply each term in the denominator and the terms are going to switch position. Now, as I put my negative sign, then I'm going to write my denominator, but I'm going to also write my denominator in the numerator. Then I do something to the numerator, to my new numerator, that will give me back my original numerator. So since I've written my new numerator as x squared minus 1, I just need to add 2, because if I take negative 1 plus 2, I get back 1. Alright, why am I doing this? So that I separate the terms. So I'm going to say x squared minus 1 divided by x squared minus 1, then plus 2 divided by x squared minus 1. These are just tricks in paper 1. Alright, so you see that the LCM is x squared minus 1, so I just need to add the numerators and divide by the common denominator, and adding brings me back to this, and everything here simplifies to this, and negative sign is here out. Now everything here is going to give us 1, right? So we are going to have negative into, we are going to have 1 plus 2 divided by x squared minus 1. So if you factorize, if we introduce a negative, we have negative 1 plus 2 divided by 1 minus x squared. I have just brought back the negative sign to multiply the two terms in the denominator. Now after doing partial fractions, after doing long division, we now need to partial fract. We now need to reduce this man into partial fractions. Now we go and check the denominator. The denominator is a quadratic, and that quadratic is reducible. So once a quadratic is reducible, we have to reduce it into 1 minus x times 1 plus x. Alright, I factorize a quadratic. Now I now have linear factors, so it's now very easy for me to work it out. So it therefore means that my original f of x will be equal to negative 1 plus a divided by 1 minus x, then plus b divided by 1 plus x. Alright, because these factors are linear factors, therefore their numerator is supposed to give us a constant. So now this is our answer, so you need to run back to the MCQ and check which one is correct. Okay, so if you look at this MCQ, you realize that option D is correct, right? Because you have A on 1 minus x plus B on 1 plus x minus 1. I think that's what we have. We have I can just carry this minus 1 and then I write it at the end. I've not changed anything. So we have A on 1 minus x plus B on 1 plus x minus 1. So question 1, option D. Okay, question 2. So in this video, I think I'm going to solve maybe the first 20 or the first 10, yes, and subsequently I'll just be solving like that. So if I end the video halfway, check the next video in the channel. You basically see a continuation, because I don't want to make the videos to be too long. All right, question 2. The integrating factor of this differential equation is, so the differential equation is x y prime minus 2y equal to x squared. So it is x dy by dx minus 2y equal to x squared. I think I wrote it correct. Voila. So how do I get my integrating factor? Step number 1 is that I need to make the coefficient of dy by dx to be 1, and making it to be 1, I just need to divide all through by x. All right, so I have something like over x here, then I have x squared over x is x. In fact, let me try to rewrite back the original. All right, so if I divide all through by x, I'm going to have dy by dx minus 2 divided by x times y equal to x. Now the integrating factor, my integrating factor is equal to e raised to the power the integral of the coefficient of y. But I'm doing this provided the coefficient of dy by dx is 1. That is why if somebody says it is e raised to the power the integral of -2, the person is false, because the coefficient of dy by dx is not 1. But if somebody says it is e raised to the power the integral of -2 over x, the person is correct. Then we need to integrate with respect to x. So this is the same as e raised to the power -2 is a constant, so we pull it out of the integral and we have the x over x. Now we have e raised to the power -2. When we integrate the x over x, we just get ln x. In fact, let's just forget about the constant of integration. Okay, but anyways, let me just put it. Yes, let me just put it. So I integrate and I put now plus my constant of integration. Now I can write this as e raised to the power -2 ln x times e raised to the power k, right? Because that's indices, you can see combine back the powers by just adding them. And this e raised to the power k is a constant. I can call that constant small a. Then e raised to the power -2 ln x is the ln of actually is the absolute value of x. Okay, but I'm just solving for the fact that x is greater than 0. Let me see if it was given in the equation. It was not given in the equation, but we just deal with the fact that x is greater than 0 so that the answer should be there. But basically they have to specify that it's supposed to be, because if they say x less than 0, then we need to indicate the absolute value. So this is x raised to the power -2 by indices. Okay, and x raised to the power -2 is basically the ln of 1 over x squared. Okay, and e raised to the power the ln of 1 over x squared is just the 1 over x squared. So this is a times 1 over x squared. So all we need to do is we need to come and verify the answers. So if in an MCQ, if they replace a with 2, the answer is correct. Okay, but fundamentally a is going to give us 1. All right, that is k has to give us 0. That's fundamentally. In fact, in most cases we just ignore the constant of integration. So you can do it without the constant of integration, but I'm just telling you that try to always do it with the constant of integration, because an MCQ, so that in case you don't see 1 over x squared when a is 1, you can take anything that is multiplied with 1 over x squared. You are very correct, but that thing has to be positive. Okay, because this e raised to the power k is positive, so this thing here has to be positive. So I have to specify that a is greater than 0. Alright, so let's go and check the answers. So the answer is B, right? Because you have 1 over x squared. Option C is saying negative 1 over x squared. This option is false. This option is false because the constant that is multiplying 1 over x squared is negative. So that is it. I think that is it. So let's proceed to the next question. Okay, so which option are we taking? We are taking option B. So question 2 is option B. Now let's go to question 3. Let's go to question 3. In the exponential form, 1 minus tanh x is equivalent to, so 1 minus tanh x, this hyperbolic function is equivalent to 1 minus, now tanh x is sinh x divided by cos x, so 1 minus, now sinh x is half into e to the x minus e to the negative x, and cos x is half into e to the x plus e to the negative x. Okay, so this will be equivalent to 1 minus, the halves cancel, and if I multiply the numerator by e to the x, okay, so I'm going to take e to the x divided by e to the x, then I'll come back and I'll multiply. I'm just going to rewrite this. I'm multiplying top and bottom by e to the x so that that power e to the negative x cancels, okay, and I'm multiplying the top and bottom so that everything should be the same because this can still cancel and we get 1. Alright, so we have not changed anything. I'm just doing it because in my answers I'm seeing e to the 2x, so there is no negative power, so we need to remove that negative power. So everything will be equivalent to 1 minus. Now when I multiply the numerator, each term of the numerator by e to the x times e to the x is e to the 2x because I need to add the powers. E to the x times e to the negative x is e to the power 0 because x plus negative x is 0, and e to the power 0 is 1, so you have minus 1, and here we have e to the 2x plus 1. Okay, you realize that, which is equivalent to the command is not going. Okay, which is equivalent to, now the LCM is e to the 2x plus 1. When you take e to the 2x plus 1, you multiply with 1, you get e to the 2x plus 1. Then we have to subtract with e to the 2x minus 1. Alright, now e to the 2x will cancel e to the 2x. 1 minus negative 1 is 2, so everything here gives us 2 divided by e to the 2x plus 1. That is it. So now we have to go and check the response. 2 over e to the 2x plus 1. 2 over e to the 2x plus 1. Option B. So option B. Question 4. So we are left with 6 questions. Like I said, I'll do 10 questions. So when you're coming next, after you watch this video, check again if I've uploaded the next video, and turn on your notifications after subscribing so that when I upload other videos, you'll just be notified that okay, I've uploaded this video. If you're liking this video, actually like it. Thank you very much. Alright, question 4. Which of the following functions has a removable discontinuity? Alright, so we have to analyze before going to the Word document. So what is a removable what have I done? What is a removable discontinuity? A removable discontinuity is just kind of let me see how I can explain this so that you understand very briefly. In fact, let me first of all look for the answer. Let me see, is it A? No. Is it B? No. Is it? Yes, it is C. Alright, now let me show you something. If I give you this function x squared, I think I'll just explain with an example. X squared minus 1 divided by x plus 1, right? You realize that if I ask you for the domain, you tell me that since it is a rational function and the numerator and denominator, in fact, since a rational function, for it to be defined, x plus 1 has to be different from 0, right? That's the denominator, which means that x will be different from -1. Alright, now if x is different from -1, the function is defined. But look at this function again. You see that the numerator is a difference of 2 squares, x plus 1 times x minus 1. Now you now see that this x plus 1 can cancel off. That is what we call a removable discontinuity, because a function is continuous in its domain, right? Therefore, if you are not in it, if you are not in the domain of definition of the function, then the function is discontinuous at u. So the function is discontinuous at x equal to -1 naturally. But now, because x plus 1, we can cancel out the factors of x plus 1, then we have removed that discontinuity, because when we cancel out those factors, we are just going to be left with x minus 1, and this function is continuous everywhere. Okay, so that's what we call a removable discontinuity, and this mostly occurs when we have a common factor in the numerator and the denominator. We just solve that factor equal to 0, and we have the values of x that satisfies. So this is just maybe a brief explanation. Recall. Alright, so I think with this we can now go back to the answers, and just by reading you can already know which one is correct. You see, x squared plus 1 over x plus 1, we cannot factorize the numerator because it is an irreducible quadratic. This other guy, we cannot also factorize the numerator. But when you come to this man, you can, in fact, this is just a similar example I've taken, right? So you see that x squared minus 1 on x minus 1. So if we talk of x squared minus 1, x squared minus 1 divided by x minus 1 can be written in exactly the same form, but though the denominator is x minus 1. Now you see the x minus 1 cancel, and we are going to have what? Equal to x plus 1. So there is a removable continuity at x equal to 1, since the factor x minus 1 has cancelled. It therefore means that this polynomial or this function is a function that has a removable discontinuity. So I think the option is option C. Option C. Alright, let's go on to question 5. We are left with 5 questions to complete this series. Anyways, I'll check how lengthy the video is. If it's not too lengthy, then I will add some other questions, because this thing is very tiring to do. Just that it was asked by so many students, and I cannot create a PowerPoint on this. It's too tedious. Alright, the series is convergent for. Alright, so when is this series convergent? This is what we call the power series, the P series, or the K series, because I replace, generally we usually have the sum from r equal to 1 to infinity of 1 over r to the power p, and we call it the P series. And the P series converges whenever p is greater than, strictly greater than 1, or greater or equal to 2. Yes, so clearly the answer is K is strictly greater than 1. I don't want to over explain this paper one. Anyways, for benefit of doubt, I think explanation will not kill somebody. So the sum from r equal to 1 right up till infinity of 1 over r to the power k. Now when they say something is convergent, it just means that whenever when you're going to find this sum, it's going to give you a particular value. Alright, now let's begin with negative values of k. If k is a negative value, if k is less than 0, right, then you realize that r to the power k will be greater than 1. Or in fact, how can I put it? Let me put it this way. If this k in the denominator is less than 0, let's say that if k is -2, right, for k equal to -2, you realize that r to the power k will be equal to r to the power -2, okay, which will be equal to 1 over, or let me say 1 over r to the power k, okay, will be equal to 1 over r to the power -2, which is just r squared. You see, so whenever the denominator is any negative number, everything here will just be everything, the n term or the k term will just be r to the power that the positive of that number. If k is -1, everything here becomes 1 over r to the -1, which is r to the power 1. Now if you're summing r squared, just think about summing r squared from 1 till infinity. It means replace r with 1, keep, replace r with 2, keep, replace r with 3, keep, then sum everything. You realize that everything is, in fact, as you're replacing r with numbers and the numbers are increasing, then what happens is that when you're summing, the sum will also be increasing, so you'll never arrive a certain value. You'll be going towards infinity, because if you replace r with 1, you're going to have 1 squared, which is 1, with 2 squared, which is 4, with 3 squared, which is 6, which is 9. So when you start summing 1 plus 4 plus 9 plus 16 and so on till infinity, everything will boil down to infinity. So it's going to diverge because it's not going towards a particular value. So whenever k is less than 0, okay, when k is less than 0, the result diverges. Now even if k is less than 1, in fact, let's talk about when k is equal to 1. If k is equal to 1, then you're just going to you're going to sum what we call the harmonic series, okay, and the harmonic series by definition diverges. So basically this thing is going to converge when k is strictly greater than 1, because, and if k is strictly greater than, strictly greater than 1, and if k is strictly greater than 1, it's going to converge, sorry. So this is just the application of the knowledge of the p series. So strictly greater than 1, k strictly greater than 1, option B. So there we have option B. Question 6, option what? Let's get to the question. The argument of a complex number 1 plus e to the -2i theta is, so my complex number is 1 plus e raised to the power -2i theta. So I prefer to write this complex number first in the algebraic form, in the trigonometry form. So this is the same as 1 plus, now e to the -2i theta is the same as the cosine of 2 theta, of -2 theta, because the argument is -2. The argument of e to the -2i theta is -2. So the cosine of -2 theta plus I times the sine of -2 theta. Okay, now this will be equal to 1. This will be equal to 1. Now since the cosine function is even, this just gives us a cosine of 2 theta, and the sine function is odd, so the negative sign will move out and we have the sine of 2 theta. Now you realize that this is a real part of the complex number because it does not contain I, while negative, the sine of 2 theta, is the imaginary part. So basically I'm just going to see that my argument, remember the argument of my complex number is tan inverse of the imaginary part divided by the real part. Yes, but now you realize that this imaginary part is negative, right, while the real part is positive. If y is negative and x is positive, you are in the fourth quadrant, so we need to attach a negative sign to this tan inverse. So you just have sine 2 theta divided by, this is tan inverse of sine 2 theta divided by 1 plus cos 2 theta. We now use the notion of half angle identity. Alright, so if I use the notion of half angle identity, it says that, I think after this I'll show you a shorter method, it's just coming to my mind now. That half angle identity says that sine theta is equal to 2t divided by 1 plus t squared. In fact, t is actually tan theta over 2. Okay, so here we have tan theta over 2, that is sine theta. So if I replace, if I multiply all the angles by 2, what do I have? this one will just become theta, because it will be 2 times theta on 2, which is theta, and this one will also become theta. Okay, what about cos 2 theta from the half angle identity? Cos 2 theta is 1 minus tan squared theta on tan squared theta over 1 plus tan squared theta. Okay, so if I want to look for 1 plus cos 2 theta, I just have to come and add 1 in front of this. Okay, now you realize that the LCM is 1 plus tan squared theta, right? Now when you have here 1 plus tan squared theta, then plus 1 minus tan squared theta after finding the LCM. Now you realize that tan squared theta we cancel with tan squared theta. 1 plus 1 is 2, so everything will give us 2 divided by 1 plus tan squared theta. Okay, so it means that my argument of my complex number will just be equal to negative tan inverse of my numerator is 2 tan theta divided by 1 plus tan squared theta, because it is sine 2 theta. Now we have to divide it with this denominator, right? So since the denominator is still a ratio, if I want to divide, I can just kind of multiply and then I invert. I think this thing was taught right in primary school. We just have to multiply and then we invert. Now you realize that 1 plus tan squared theta we cancel with 1 plus tan squared theta. 2 we cancel with 2, and we are going to be left with just tan theta. So at the end of the day, we have negative tan inverse of tan theta, right? Tan inverse of tan theta is theta with all conditions applying. So you have negative equal to negative theta. So the argument is negative theta. Yeah, so let's check the answer. Option B is correct, negative theta. While solving, I had something in mind. I don't know if it's going to work, like a shorter method. It came, now it has gone back. Let me just think again. If we try to convert this 1 into a complex number, right? This 1 like this, I don't know if you can convert it to a complex number, because this man, anyways, I will come back to it, but it's a very short method. I've just forgotten. And in fact, anyways, let's just proceed. I'll come back to that. Question 7.